Today we're going to talk about a special type of covalent compound. We call these organic molecules because they contain carbon. And these are a special type of organic molecules called hydrocarbons. Hydrocarbons are much simpler in structure than many of the other organic molecules, but you might have heard the term organic molecules in biology when you talked about carbohydrates, proteins, lipids, or nucleic acids. So we're talking about things that are found in living organisms. They're made up of carbon. In this case, hydrocarbon contains only two elements, and as that name implies, it contains hydrogen and it contains carbon. Unfortunately for us, the hydrocarbons have a different set of prefixes than the general covalent compounds do, or at least some of them are different. The first four prefixes that we will use are different than the prefixes that we use for our other covalent compounds. The prefix for 1 is meth, for 2 is eth, for 3 is prop, and for 4 is bute. After that, everything's the same. So if you remembered them from before, you're good to go now. These prefixes are only used to tell us the number of carbons. So that's a really important point. There's nothing in the name that directly tells us the number of hydrogens. We have to do a little bit of critical thinking to figure that out. There are three main types of hydrocarbons. The first type we're going to talk about has a single bond. A single bond means that these two atoms are sharing a single pair or two electrons. We call these hydrocarbons with single bonds alkanes, and the name of them is ANE, or the end of the name of them is ANE. So if you look back at the word alkane, the suffix there is the same as the suffix that we'll use for these names. The general formula for alkanes is carbon. The number of carbon we're going to symbolize with an N. Remember, the prefixes are going to tell us that. And then hydrogen, to find the number of hydrogens, we're going to take 2 times the number of carbons plus 2. Okay, again, that's a formula that you probably want to know. Now let me show you why this is the case. If I draw the formula, the structural formula for ethane, F tells me that I have 2 carbons, so I'm going to have a C2. The hydrogens are going to be 2 times 2, that came from the carbon, so 2 times 2 is 4, plus 2 more is 6. Okay, when I draw this, I have a carbon with a single bond to another carbon. And then each of these carbons is going to have 3 hydrogens on it. Remember that most elements need to have 8 valence electrons in order to be stable. So each of these lines that I'm drawing represents one pair of electrons that the carbon is sharing with another atom. If I look at this carbon, it has 2, 4, 6, 8 valence electrons, so it's stable. And this carbon has 2, 4, 6, 8 valence electrons, so it's stable. Each of these carbons has to have the 3 hydrogens on it, otherwise it doesn't have a full octet and it's not a stable compound. So that's an example of a single hydrocarbon, also known as an alkane, and this specific one has 2 carbons, so it's called ethane. If we look at hydrocarbons with double bonds, double tells us that it shares 2 pair of electrons, or 4 total electrons, and we call these alkenes. So as you can imagine, these are going to end in ENE. Little bit different than our single bonds, so this suffix helps us figure out what kind of bond we have. Double bonds are stronger bonds than single bonds because they're sharing more electrons between them. The formula for alkenes is CN. Again, the prefix tells us the number of carbons that we have. And this time we're going to have H be the same as 2 times the number of carbons. So again, let's look at an example of this. I'm going to look at ethene. So still I'm going to have 2 carbons because my prefix is eth. But now I'm going to have 2 times 2. I'm only going to have 4 hydrogens. If I look at the structure of ethene, I have 2 carbons, but now I'm sharing a double bond between these 2 carbons. That's what the suffix "ene" told me. So these 2 carbons already are sharing 4 electrons. That means that each carbon can only share 4 more total electrons. So this carbon has 2 electrons with this hydrogen and 2 electrons with this hydrogen. I'm going to do the same thing over here. This carbon has 2 electrons with that hydrogen and 2 electrons with that hydrogen. So each carbon has 2, 4, 6, 8 total valence electrons. Same over here, 2, 4, 6, 8. So again, it has a stable octet, but because it shares this double bond, this has fewer hydrogens than ethane did. And again, if you memorize the prefixes and you memorize your formulas, this will be easy for you to figure out. The last type of hydrocarbon we're going to look at are hydrocarbons with triple bonds. And so, as you would guess, triple bonds mean 3 pairs of electrons, or 6 total electrons. We call these alkynes. So you can see the pattern here. The suffix is going to be "-ine". And hopefully you're starting to see the pattern here also. The formula that we're going to use is CN. Again, N comes from our prefix. That tells us the number of carbons. To find the number of hydrogens, we're going to take 2 times the number of carbons minus 2. So now, because I have a triple bond, which is even stronger than a double bond, I'm going to end it in INE, and these are my alkynes. So if I look at ethyne, right, eth tells me I still have 2 carbons. I'm keeping that the same. But now to find my hydrogens, I take 2 times 2, which is 4, minus 2, which is 2. So ethyne only has 2 hydrogens. I'm going to again draw my 2 carbons. These carbons have a triple bond. That came from the name, so ethyne told me it was a triple bond. And now I only have 2 hydrogens. 1 hydrogen is going to go on this carbon, and 1 hydrogen is going to go on this carbon. This carbon has 2, 4, 6, 8 valence electrons, and this carbon has 2, 4, 6, 8 valence electrons. So they both have a full octet. They're stable. So you can look at the difference between having a single bonded hydrocarbon, a double bonded hydrocarbon, or a triple bonded hydrocarbon. Most of what we'll talk about and that you'll see in here are the single bonds, but I want you to see the double bonds and triple bonds just in case. So if we do some practice, here's the formula that I'm looking at. I have CH4. Remember, I'm going to use the prefix that tells me how many carbons I have. I have only 1 carbon, so my prefix is going to be meth. To find my suffix, I have to figure out if this matches up with my single bond, my double bond, or my triple bond. So I can look at the formula. I can say that C is 1, 1 times 2 is 2, plus 2 gives me 4. So that shows me that it fits in with the alkane formula. Or I could try to draw what this is going to look like. There's no other carbon for this to bond to. So this carbon is going to have 4 hydrogens, 1 on each side, and those are all single bonds. We can see that here if I look at the picture. So when I look at the suffix, my suffix is going to be -ane. This is methane, right? Just like natural gas, methane, CH4. If I do another one over here, I'm going to look at decane. Dec tells me 10. That's my prefix for 10. So I know that C10 is going to be where I'm starting. And then ANE tells me I have a single bond. So I have to look back up here. To find the number of hydrogens, I'm going to take 2 times my number of carbons. So 2 times 10 is 20. Plus 2 more is 22. So C10, H22 is decane. And again, I could draw this out. I could draw 10 carbons all in a row and hydrogens all around them, surrounding them. Right? There are actually a lot of different structures for decane and the way that things are situated. It gets even more complex when we add more carbons or add double or triple bonds. For right now, we're looking just at the most simple, a single chain of carbons with hydrogens around them. I want you to try to do this on your own for octene and heptene, and then for C3H6 and C6H10. Go ahead and pause the video, try one of those, and then come back. So I know for octene, the oct tells me I have 8 carbons. So I'm going to say carbon, I have 8 of them. Ene tells me that it's a double bond. So if I look back up at my formulas, I'm going to see that to find the number of hydrogens for alkenes, I just take 2 times the number of carbons. 2 times 8 gives me 16. So the formula for octene is C8H16. Hopefully you got that one right. Go ahead now and pause the video and try to do the same thing for heptine. So the prefix hep here tells me that I have 7 carbons. So I'm going to go ahead and do that. C7. Ine tells me I have a triple bond. And so when I look up in my formula, I'm going to take 2 times the number of carbons minus 2. That will tell me how many hydrogens I have. So 2 times 7 is 14, minus 2 is 12. Heptine is C7H12. Again, if you need some more help, we can go over these in class tomorrow. But I want you to go ahead and try to finish up here by writing the name for both C3H6 and C6H10. Pause the video and go ahead and try both of those. So here I know that if I have 3 carbons, my prefix is going to be prop. And I have to figure out if I have a single, a double, or a triple bond. So if I have a single bond, 2 times 3 would be 6, plus 2 would be 8. I do not have 8 hydrogens here, so this is not an alkane. If I have a double bond, my formula is 2 times the number of carbons, so 2 times 3 is 6. I do in fact have 6 hydrogens here, so I know that this has to be an alkene. So if my prefix is prop, I'm going to end it with ene. C3H6 is propene. I can do the same thing over here. If I have 6 carbons, my prefix for 6 is hex. And again, I'm going to try to figure out if I have a single, a double, or a triple bond. So 2 times 6 gives me 12. If I added 2, that would give me 14. So this cannot be an alkane. Again, 2 times 6 is 12, so I don't even have a full 12 here. I have less than twice the number of carbons. That tells me that I have to be looking at my alkynes. 2 times the number of carbons minus 2. So 2 times 6 is 12, minus 2 is 10. That tells me that this is hexine. So again, make sure you understand how to write both the names and the formulas for these hydrocarbons, and we'll go over more of this in class tomorrow if you need some additional help.